Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aminul Rafi bin Syarul Azman and my group members is Aisyah and Muhammad Safi. Today we are going to present about the general filter consideration. So basically there are three parts that we are going to present. First one is filter, voltage regulation and ripple. Second one capacitor filter, and the last one is RC filter. So next, ideally, a power store filter eliminates the fluctuations in the output voltage of a half-wave and full-wave rectifier and generates a constant level DC voltage. So the elimination process is important because the many electronic circuits needs a constant or consistent source of DC voltage and current to supply energy and power biasing for proper performance. In addition, voltage regulation in power supplies is usually done with integrated circuit voltage regulators. A rectifier circuit is also needed to change or turn a signal having zero average value into one that has non-zero average. Next. The small or minor fluctuation in the output of filters are known as ripples. Basically, if the output voltage of filter circuit is regulated by using DC voltmeter and AC RMS voltmeter, the DC voltmeter will indicate and records only the DC level of the output voltage or the average. For the AC RMS meter, it only indicates the RMS value of the AC element or component of the output voltage. Ripple can be calculated by formula R equivalent to ripple voltage RMS divided by DC voltage and times 100%. So the amount of the DC output voltage difference over range of circuit performance is another part of importance in a power supply. When the load current is moved from the source, the voltage provided at the output under no load condition is reduced. The number of a DC voltage alternates between the no load and load condition is described by a factor named voltage regulation. The voltage regulation is equal to no load voltage, full load voltage divided by full load voltage. Next. Capacitor filter. So basically, the capacitor filter can be defined as a capacitor that is introduced to filter the specific desired frequency signal. The parallel plate capacitor is connected and attached from a rectifier output to ground and placed directly across the load resistor RL. The capacitor filter can be designed to pass low frequency signal and high frequency signal, or even a certain branch of signal are also filtered with this type of capacitor. The output frequency of a half-wave rectifier is 2 times smaller than the output frequency of full-wave rectifier. Therefore, the full-wave rectifier is easy to filter and clarify due to the short time between the peaks. Next. We will discuss about the filtering process of a half-wave rectifier and expand it to the full-wave rectifier. In the figure 1, we can see that the diode is in a fault bias condition of the first quarter part of positive cycle of input signal. During this cycle, the diodes get charged to within 0.7 volt of the peak value of the input. In the figure 2, we can see that when the input signal moves to a decrement from a peak point during this process, diode is become reverse bias and the capacitor is still charged. Throughout the residual portion of the wave, the capacitor can release charge only over the load resistor RL at the rate defined by the RLC that the time constant is longer than the time interval of input signal. In the figure 3, the first quarter portion of the next cycle of an input signal is shown. Diode is a biasing condition when the value of input voltage is larger than the voltage stored in the capacitor by almost 0.7 volt.
Next, by using the RC filter as the additional section, it is possible to further reduce the amount of ripple across a filter capacitor. Basically, RC filter consists of capacitor and resistor. The figure shows the second order of RC filter circuit, which the additional RC filter will be put in between the capacitor filter and the load circuit. The general purpose of RC circuit is to filter a signal by blocking or reducing the certain frequencies and passing the other frequencies. So, the purpose of the added RC filter is to pass most of the direct current component while blocking or reducing as much as possible the alternative current component. Basically, there are two types of RC filter, which are low pass filter and high pass filter. The difference between these two is the position of capacitor and resistor in the circuit. For the low pass filter, the position of capacitor will be in parallel with the voltage, while the position of resistor will be in series with the voltage. The low-pass filter will pass the signal that has frequency lower than the cut-off frequency and will attenuate or reduce the signal that has frequency higher than the cut-off frequency. For high-pass filter circuit, the capacitor will be in series with the voltage while the resistor will be in parallel with the voltage. High-pass filter will be used to pass signal that has frequency greater than the cut-off frequency while blocking or attenuating the signal that has frequency lower than the cut-off frequency.
AC voltage will be filtered to DC voltage by capacitor filter and additional RC filter. The figure shows full wave rectifier with RC filter. The resulting DC voltage usually will have some ripple or AC variation. That's why it has the DC and AC components of the signal. These two components can be analyzed by using the superposition.
For the DC circuit, the DC voltage level will be developed across the capacitor C1. Since both of the capacitors are open circuit, the resulting output DC voltage will be equal to RL over with R plus RL times with this VDC.
Lastly, for the AC equivalent circuit of the RC filter section, AC ripple voltage will be developed across the capacitor C1. Due to the voltage divider action of the capacitor AC impedance and the load resistor, the AC component of voltage resulting across the load is approximately equal to XC over with R times VR RMS. XC is the impedance of capacitor, which is equal to 1.3 over with C for full wave rectifier with AC ripple at 120 Hz. That's all from us. Thank you.